Thriving ecosystem requires you to have exports and imports both, right? You have to import people from different perspectives, disciplines, compound the knowledge that you have and sort of export that out as well back into the world. Our best kind of customers are customers who tell us that you can't meet this quality or can't meet this price. I don't think that any company in India is doing this right now. We've taken a lot on our shoulders by expanding it. But I think sometimes doing the hardest thing is, probably the best thing. If you are not making money, I don't think I have a right to be making money. They're suppliers that is like a marriage, right? Once you're married, it takes heaven and hell to change that.
Spend time on the shop floor.
It is the hardest thing you will ever do.
Hi everyone, welcome to another episode of Zero to Infinity. I am Sudipto and with me we have today Karan and Himanshu, founders of Wootz.work. As Z47, we are very fortunate to partner with both Karan and Himanshu in their journey as they build India's largest advanced engineering exports company. And today we will cover a little bit of their backgrounds, their journeys in life, what got them excited about building an engineering exports company out of India, and what's the vision for Wootz. So thank you so much for taking the time out. Before I start, I would love to understand what does Wootz mean and where does the word Wootz come from?
Yeah, so quite interesting, and it fits in very well with what we try and do. So Wootz was actually a steel forged in India about 3,000 years ago in Golconda. So it was a high carbon steel. Pride was that it was very lightweight. Played many roles in history. It was Tipu Sultan's sword was made out of it. So India was one of the largest exporters of that type of steel. It got exported out, became Damascus steel, became Sheffield steel and all the types of steel. Now what's funny is as of today, no one makes that steel anymore and you can't even get a sample of it. So very true to that nature of having engineering here, exports over here, and taking engineering to the world again is something we take very passionately, and Wootz inspires us to do that again.
Between the two of you, who knew about this story first and proposed the name?
It was actually Himanshu's wife.
Yes.
Okay, wow, that's very, very interesting. Maybe let's cover a little bit of both of your journeys, and Karan, I'll start with you. Obviously, you grew up in Delhi, worked for an investment bank, then spent a lot of time with Invest India, went to Stanford GSB, worked in a sustainable packaging company Zoom, and then decided to start up, right? And I know when we have spoken in the past, both your Invest India stints and your time at GSB deeply influenced how you sort of think about engineering, exports, and are one of the reasons behind why you started Wootz.work. So maybe give us a little bit of color on both those two stints. What did you see on the ground, and sort of what led you to starting up?
Yeah, sure. So I think Invest India was one of the most rewarding experiences, working with the government, multiple sort of departments, multiple ministries, many clients. I think what we could see at Invest India back then was, sort of a trailer for what was to come, which is now coming, right? There was companies, multi-billion-dollar companies looking at India to sort of invest, set up factories, plants, figure out how supply chains can get more linked into India, right? But there were still issues at that time. There were issues, GST, setting up factories, ease of doing business, logistics. So all those things were being
considered. And this is which year?
This was in 2016.
Got it. So very early in the journey of Invest India.
Yeah. So we could see this massive intent coming, but it wasn't sort of going at the pace which you're seeing is going now. These things take like 5, 6, 7 years to actually reach momentum. Similarly with startups, I used to look at Startup India as well. Over there, you would see a lot of startups, but a lot of those were actually startups which were modeled on Western startups, but you could see shoots of really deep tech startups, right? People building capabilities from the ground up, from universities, from engineering colleges. So that was very interesting, but I knew it was 3 or 4 or 5 years out before all this was sort of come together, but it was very interesting, and it was more like a trailer teaser of what was to come. So that was one part of it. Being at GSB, of course, it's living, breathing that air. It's an innovation engine, if I were to call it anything. But what I took away the most from there is that, what does it take to build a thriving ecosystem? Thriving ecosystem requires you to have exports and imports both, right? You have to import people from different perspectives, disciplines, compound the knowledge that you have and sort of export that out as well back into the world. We view the same thing as engineering, clubbing both those experiences.
And this is very interesting. Like whenever we speak, most of the time we speak about exports out of India, make in India, build for India and for the world. We rarely speak about imports, but this is a very interesting point. And if I get it correctly, you are saying that if you have to build a thriving exports hub, you should be great at imports as well.
Absolutely. I'll give you some real life examples. So we, got a couple of million in contracts and working with some very, very large multi-billion-dollar customers. Very often we've had to import technologies in. Some of our high volume products, the supply chain actually begins in Taiwan. Some of our equipment processes didn't exist in India, so we had to actually import that machine, install it on our supplier sort of line to make sure that the entire process can give the output desired by the customer. We've had to export people to be trained on certain skills internationally, get them back and train our people over here. We import a lot of specialty raw materials. So it's a two-way street, right? To have sustained margins, and we enjoy a high margin stack, you have to be able to sort of import and compound the knowledge that you have, multiple processes and supply chains.
And which is fair. Like even if you see China, and whenever I visit China and go to their factories, I think two things that they do a very good job in importing is, first, I think raw materials.
Yes.
They have very strategically tied up with multiple countries across the world for raw materials, right? The lithium and the cobalt and the nickel that they actually build batteries out of, they're all imported, right? And second, if you go to China and look at their lines, all the normal non-intelligent assembly lines will be China built, but all the machinery which has intelligence inbuilt into it will either be Japanese, Italian or German. So in the end, I think the right raw materials and the right quality of machinery has to be imported, because obviously there's only one ASML that can do what they do, right? So good, very interesting point, and we'll go deeper, Karan. But before that, Himanshu, obviously when I go back, you are a year junior to me from Kharagpur, and then you went to ITC. Very few companies out of IIT which actually look for manufacturing talent, right, or engineering talent. And I know you are very passionate about this topic. So tell us about your time at Kharagpur, at ITC, and sort of what inspired you to start up.
Thanks, Sudipto. First of all, as I call you Dada from Kharagpur. But yes, Kharagpur was a very, very inspirational time for me. As a young engineer, learning a lot of stuff around mechanical, electrical, all of that stuff. But the biggest challenge that I saw at Kharagpur was the lack of really highly skilled technical jobs in the market, which was a bit surprising for me, right? Studying engineering at one of the best colleges in India, and I didn't have enough number of companies who could offer me a great engineering experience to build. However, I didn't really worry much about it, but by the time placements came, what I understood was whatever few companies exist, ITC, which finally recruited me, was one of the best companies which would give me some inroads into engineering. In fact, funny enough, I remember during the placement time, I was looking for engineering companies to apply for, and there was only one. And by the time all the shortlists came out, I realized there was only one company I was shortlisted for, and there are no other engineering companies to apply for. But lucky enough, I got selected at ITC, and then it was sort of a very crazy journey getting into the real market, on-ground manufacturing factories. At ITC, I was basically a project manager. Luckily for me, at that time, Mr. Y.C. Deveshwar, who was the chairman of ITC, had this vision of building the largest plants and the most automated plants in the country for the foods business of ITC. Close to $1 billion of capital was sort of allocated for that project, and I got sucked into that project naturally. That sort of gave me a lot of exposure to a lot of Indian manufacturing companies, which are mostly SMEs. But at the same time, I also got to work with a lot of Chinese companies, a lot of European companies importing that technology, like Karan was mentioning. The kind of young engineer that I was at that time, it felt like, why am I importing all this stuff when I am an engineer and I can build all this, right? So in all that energy, I sort of left my ITC job after 4.5 years of very rich experience of the SME ecosystem and got into manufacturing pretty early. Came down to Pune, started designing manufacturing machines, etc. and started looking at all the problems that actually existed on the ground, which I was sort of noticing earlier as well. But at that point in time, I couldn't really find a solution.
So I'll pause you here, Himanshu, as you speak. And I know that we have spoken in the past and you have said that India mein manufacturing to ho jata hai, but engineering nahi hota. And with Wootz, you want to be India's largest advanced engineering export. So maybe first share a little bit about, in your mind, what is the difference between manufacturing and engineering, and then we can chat more about what you did at Pune.
Look, so I think fundamentally engineering is nothing but application of natural sciences, mathematics to really solving problems, right? Manufacturing, on the other hand, is manifesting those ideas into real products on the ground, which requires a bunch of different technologies. But the output of engineering is really solving problems on the ground. If you think about manufacturing, it inherently isn't really a scalable business, right?
Why?
Because, manufacturing requires three main things, right? Let's say we call them the 3 M's, right? You need machines, you need manpower, right? And you need materials, right? All of these three things scale linearly with your production capacity. You can't really scale without materials, without manpower, without machines. However, on the engineering side, right, which allows for compounding of knowledge, right, that is inherently scalable, because one design, one problem that you've solved can be applied to various different industries, various different sectors across, right, and can really generate disproportionate outcomes.
Which is very interesting. And if I understand it correctly, you're essentially saying India has a lot of manufacturing.
Absolutely.
Which is more build to print, where you get the design and the engineering solution, and we essentially manufacture, because obviously cost of labor in India is cheaper, cost of power in India is cheaper. So obviously the cost of manufacturing in India is cheaper, which
Absolutely.
we keep hearing on. But we truly don't have the engineering design capability.
Correct.
Which still probably rests with most of the Western countries and OEMs.
Absolutely, which also is very, very cost efficient if you look at it, right? Engineers in India, probably if you think about it, India is producing about 1.5 million engineers every year today, right? That's about 20% of the world's engineers being produced in India, right? I can't say how many of those are really actually working in the engineering space or in the manufacturing space, given so many opportunities, right? But if you even think about the next 20 to 30 years, right, these number of engineers will keep growing, and we are sitting at a cusp where potentially 2 to 3 decades hence, we will have almost 30 to 40% of the engineering manpower, engineering workforce of the world, right? And that has been sort of one of the biggest insights we've had at Wootz.
Got it. Understood. And I know after that you spent time with Pune starting up, and then you guys met at Zoom and you decided to start Wootz. While starting a Wootz, right, there are a bunch of choices you guys took. First, to build something in manufacturing and engineering in India. That was choice one, which seems to be obvious given your backgrounds. But within that, why choose engineering? Why choose exports, not domestic? You guys started with Europe and ANZ, whereas traditionally people have started with US. So bunch of choices you took at the very beginning, right? Which has led to early PMF for the company at a very, very quick pace. So tell us a little bit about what are the deliberate choices you took while starting Wootz.
I think one interesting thing is that, how Himanshu and me met. Like, I think I was responsible for setting up these new factories in our former employers, and Himanshu was the head of engineering. So we were on these shop floors getting hammered, right, by these, the owners of the factories are joint venture partners. Why is this not happening? This is not moving fast enough. That's how, within all this pressure, a lot of, our insights were formed. In fact, I was also the first person to interview him.
Yeah.
And from the first conversation we had, it was meant to be half an hour interview, it went on for 2 hours. We had already started thinking about Wootz then. That, with my experience, hey, Himanshu, there are like so many SMEs over here, this is going to explode. And, Himanshu's insight, that, there is real good engineering possible over here. And this market is going to be inherently SME driven. This market is going to grow only and scale only in terms of exports. So that's how a lot of this was born. But
And sorry, Karan, before the choices, maybe very quickly, share a little bit about what the Wootz model is today, and then you can talk about the choices.
Yeah, sure. So, like you said, we're an advanced engineering solutions company. What you rightly pointed out between manufacturing and engineering, Himanshu was also mentioning is, build to print versus build to spec in a way also, right? Build to print is, you are given a very set clear of drawings, very clear tolerances, specifications, materials, and the job is to manufacture them. So that's one part of the value chain. We do some parts of that, but we do it in a more advanced level with very high tolerance, etc. Where we exist is what we call build to spec. Spec is where the customer tells us a problem, right? I need a component, a sub-assembly, a machine, an entire line that can do this for me. Our best kind of customers are customers who tell us that you can't meet this quality or can't meet this price. This is what gets us excited. So there we start with the engineering of it, right? We have some of the best engineers in India, and we really pride ourselves in the engineering talent. We'll talk a little bit more about that. Starts with the basic engineering of it, the processes, 3D simulations, getting the client on board, the calculations. Then it goes into prototyping. Then it goes into building out a bill of materials. Building out a bill of materials and making costing work by making sure there are not so many custom parts. We will use as many bought outs as we can, modifying the design and the BOQ to the context of the customer. If a customer is sitting in a food factory in Germany, it requires a certain amount of engineering versus a customer sitting in a warehouse in Australia. So there is whole different set of standards. So anyway, from there we go into manufacturing, which we control. Manufacturing all the way from individual expensive piece of equipment to scalable, 3 million, 4 million pieces a year. So we have the capability to work on those scales. From that to packaging, you'll be surprised how many things get damaged in packaging as well. All the way to logistics, customer delivery, and after sales. So we manage the entire sort of value chain and giving the customer a seamless experience. I don't think that any company in India is doing this right now. We've taken a lot on our shoulders by expanding it, but I think sometimes doing the hardest thing is, probably the best thing. We could not leave the remaining bits in the control of others, right? The expectations of quality, to give you, some of the fabrications we do are large 3x3 meter structures. We make hundreds of these pieces with 1 mm tolerances. We do a couple of things for the food and beverage and pharma industry, which are sub 5 micron? Yeah, sub 5 micron tolerances. So doing that at scale again and again, applying that across industries and compounding that knowledge is probably where we really pride ourselves. So yes, we're an engineering first company. We can work on multiple complex projects and scales varying from a couple of pieces of equipment to entire component lines.
So with that right now, maybe let's come to the choices. So why take the engineering part? Doing manufacturing is much easier. Getting larger orders and just doing build to print is easier. So why do engineering? Why do exports? And within exports, why did you start with EU and Australia, New Zealand?
So maybe Himanshu can talk about exports. I'll talk about why we got into this. So the real macroeconomic opportunity in the product categories we chose, Sudipto, are light engineering, as you know. How light engineering is different from other engineering is the input component of manpower is high, right? Which gives you a huge arbitrage. All things equal, if you have a 30-40% manpower in the input cost, and even as of China today, I can say that the average Chinese welder is about 3 times the cost of the Indian welder. Raw materials, power and all aside, they're more competitive, but you have a chance to, meet or break their pricing while exceeding quality. So there's a real strong competitive advantage in the category, macroeconomically at least. Layering on that, of course, is process efficiency and supply chain maturity, but that's one part light engineering, maybe exports you can sort of talk about. And I'll take up
I think from an engineering point of view, it's sort of rooted in a personal story as well, right? So when I left my job at ITC and came down to Pune, I started hiring designers, I started hiring engineers to design machines, manufacture all these machines. And initially I didn't really realize this fact, but I was hiring very good quality engineers at 12,000 rupees, 15,000 rupees per month. And I thought to myself that all of these engineers who've spent lakhs of rupees in their education, who've spent lakhs of rupees in technical professional courses, right, are doing jobs at such a low cost. And ultimately what happened, all of these engineers would either learn Python or they'd learn some language and then leave for IT jobs, right? And that sort of became a trend. It kind of became a nagging issue for me because every time we were training people, we were improving their output, and within a few years they would be gone, right? So there was no real compounding happening in the engineering industry. And that was a very personal challenge that I took, and I thought to myself that, without this compounding, we are really not moving anywhere, right? We start from the same point and we end up at the same situations. So that was why I think engineering I got really passionate about solving this challenge for the Indian engineering ecosystem. In terms of exports, I think a couple of things probably slightly controversial as well, but my own experience with the domestic market, because when I started my engineering and manufacturing journey, I was only working for the domestic market. But what I realized very quickly was that if you leave the top few customers in India in every sector, right, most of the companies, right, most of your customers would actually create a race to the bottom for the manufacturer, right? You would be pressed for quality, you would be pressed for cost, and everything just keeps moving down. And that was a very significant problem that I saw across the industry. But when you compared that with the international clients, right? International clients, number one, had the paying capacity, especially if you look at developed countries and the customers there. They had.
And obviously, you're making a very valid point here where you are saying that the appreciation of high quality engineering
yes.
is still not in India, because probably the end customers in India finally will sell to a set of customers who also won't be willing to pay a premium for the delta that you get, right?
Exactly.
So export quality versus domestic, right? When you say they appreciate higher quality, what does it mean? Can you like give some examples on most of your customers, as I'm aware, are substituting German products or Italian products with your products today, right? So what is the delta between Indian manufacturing engineering to say what they get in Italy? How are you bridging that? And in that way ensuring that you get the right premium and finally the engineers get paid their dues.
Correct. Now, I think, look, quality extremely subjective, right? But in macro terms, when you think about, again, the same three M's, right? Machines, manpower, and materials. Obviously, you need higher quality materials, which we were talking about, that we import, right? Very high quality machines that can achieve those 5-micron precision, right? You need trained manpower, right? All of these are the macro points. But to be honest, I think what we have been solving for is compounding of all of this knowledge, right? How do you really solve for those small things in manufacturing which are extremely difficult to define, right? Macro things that look easy to solve, right? You can import raw materials, not a big deal. You can get manpower trained at different locations, not a big problem, right? You need to import machines, capital. I think if you're solving the right problem, you have access to that capital. But even with all of these three things, you cannot guarantee quality, right? And that lies in the culture that you're building in manufacturing, right? In fact, and that's why when you asked why are we into exports, right? We feel that unless you have a culture of manufacturing high quality goods, right, you cannot really build a successful company. And if you're doing the same job for the domestic market and for the export market, it's extremely difficult to really switch between these two quality expectations, right? So that's why we sort of set about solving for exports, creating high quality capabilities, high quality capacities specifically focused on exports, and compounding the knowledge that we are sort of gaining with every opportunity, every order that we work on, and every engineer who's joining us, right? How do we compound his knowledge? How do we improve his performance? How do we improve the timelines in which we are delivering goods? How do we reduce costs, right? Resource efficiency, cost efficiency are extremely important things which probably, again, slightly controversially, but because a lot of these things are very cheap in India, right? We've not learned to respect them, right? We don't use them efficiently. And that is also a wide problem culturally across, right? Whether it's from my office, whether it's using those small cups that we use for tea, or whether it's paper, or whether it's manpower. We're extremely wasteful. And solving for all of this requires solving for the culture that you're building. And that's the culture we require for manufacturing for exports.
On that race to bottom point, I'll just give an example of, we have a customer in Germany. Now we gave pricing for a contract, and it was very competitive cost, and the customer called me, was worried that, Karan, I hope you're making money out of this. This is pretty low. I said, why are you worried I'm making money? He's like, look, if you need to be incentivized well to innovate further, right, to make sure I get the quality I want. If you are not making money, I don't think I have a right to be making money. And like Himanshu says, you play that same game in India. I mean, you can't even openly say that. I have to finally tell the customer, like, this is my margin. He said, good, I'm happy. Here you say that, the guy will squeeze you and go to the next guy. So there is a value they put to it. There's a value they put to partnerships. And touch wood, till now we haven't lost a single customer.
Absolutely.
Every customer we've gotten in with has been sort of stuck with us, more and more RFQs, more and more orders. We have companies which are a couple of $1 billion moving massive amounts of procurement and have close to 500 member teams in India still working with us. And we're just 23, 24 people.
Got it. So very, very interesting. Now getting back to the point on Europe and ANZ and UK, right? How did you choose your geographies?
I think, let's pick up EU, and I'm just going to refer to EU and UK, both as EU. Now, what people don't realize is, as a contiguous region, it's very large, right? EU has a population with UK of around 450 million. The US, as a comparison, is 330 million. It also has half the landmass that the US has, which means a very high density of population, which means that our salespeople can actually cover a lot more ground. So that's one part of it. Interestingly, also, from a commercial point of view, it imports $2.1 trillion of engineering goods from the world. The US same HSN codes imports about $1 trillion, right? And India's share in this 2.1 trillion is just about 1%, growing at 20% CAGR. So what really excites Himanshu and me is that rarely in history do I think founders get to sit and see $1 trillion opportunity in front of them. Again, there are more nuanced factors. There's less distance to market. There are common engineering standards with India. Entering another European country, CE certification, etc., does not require me to completely change the supply chain. So those are a couple of interesting things. One more insight here is that we believe the problem of availability of quality engineering is much deeper in EU. The median age in EU is 44 versus the US where it's 38, right? Meaning less and less people are joining the workforce, meaning that there generally is a talent shortage. We have a customer in Germany, we got that order, who was actually waiting for the response of an RFQ for 3 months. I mean, to us, that's a sin, right? That's a problem to be solved, a customer willing to pay. We gave that quotation in 24 hours, an entire proposal, and we got that order.
Got it. Interesting. But obviously, culturally, they're very different. I'm not sure, but the nuances in selling in Germany might be very different from Italy. So how do you solve for sales? Everybody in India wants to do exports. The challenge is it's very difficult to get high quality export orders, and how have you solved for that?
I think great question, and I think it's nuanced across countries, and it's nuanced also how people view their existing suppliers. We have a person in Italy on the ground, so rule number one is that you don't have a right to sell to these people or demand large orders till you have someone on the ground covering and servicing them. Someone who understands their language, understands their local context, can speak with them. They have a phone number to call, a handshake to be done, or a scold or a slap in the wrist. Like, it makes people real. So I'll tell you, Italians, for example, breaking into Italian, we've just on the cusp of doing that. Supply chains are very difficult, and Claudia, who covers that region, tells us that they tell their suppliers that it's like a marriage. Right? Once you're married, it takes heaven and hell to change that. They're not going to move for 5, 10, 15%. It's going to take margins way ahead of that, or cost economics more than that. It's going to take a very strong amount of after-sales service, right?
Which is very European, not American, by the way.
It's not, yeah.
They're significantly more commercial.
Correct. And the opportunity, the flip side of this is that once you're in, right, we get in sometimes with a small part, a small component, whatever. Quality of service, quality of delivery. Sometimes we even make recommendations that, hey, we could save costs further by doing this. Value engineering, right?
Who are you replacing them for? Is it another European light engineering company? Is it a Chinese company? Is it an Indian company?
Yeah, so if you look at the spectrum of products that we offer, we start from hardware consumables all the way up to entire systems, right? So in let's say fabrication, I'll pick up as an example. You're replacing one of two things. One is definitely a local market supplier, which is your local Italian, German, maybe some specialty process people, let's say a Belgian, etc., but within the EU region. And the second thing you're replacing is the capex someone may do to bring that in-house. So you have to keep thinking that, does the economics of this product work for that person to do this in-house, right? If they do that, that's not the right category or the right territory for you to be playing in. So yeah, more often than not, we're competing with local suppliers. When you come to the system integration end, you're dealing with some niche system integrators across Europe. You're also dealing with system integrators from China. Another concern that keeps coming up, and I've heard this on the factory floor in UK, is right that people are not wanting to import vision-based systems, etc., from there because the data is not housed within the UK. It's actually housed in China, and there was no way to sort of delineate that with equipment from China. So these are ground realities, right? Even them being maybe a third more competitive than the local market, are not being able to win orders because of concerns of data security, integrity, IP, etc.
Got it. Interesting. And I'll hold you onto the margin point here and sort of ask a question very close to my heart. I have obviously been a big believer of Make in India and B2B commerce and supply chains, investing in over 10 odd companies, right? So coming from a little bit of personal experience, traditional supply chains, the challenge has been that obviously you don't do any capex. You can scale very fast. It's a non-linear business, but you don't make enough margins. Traditional manufacturing, you make enough amount of margins, you can get to 15-20% in overall net margins in a company, but you need to put a lot of capex, which makes it linear. Obviously, you guys are trying to build something which is non-linear with very high margins. How is it possible? What are you doing? And give us a little bit of flavor of what is Wootz.work's business characteristics.
Yeah, so I think I'll take the financial, the commercial bit of it, and Himanshu can talk about the supply. So, ranging from various categories, right? Hardware, consumables being high volume products, where also there's significant margin advantage, all the way to system integration, which are low volume but very high value products. So the lower end of the spectrum is like, 80 to 20%, the highest being excess of 45% gross margins at times. What's very interesting is now,
What lets you command those margins without owning the manufacturing?
So it's not always about, actually maybe Himanshu, you better take this thing.
No, I think the answer lies in the question whether we are a manufacturing company or an engineering company, right? We are selling engineered solutions, right? We're not selling build to print manufactured components alone, right? And when there is contribution of engineering, right, the solution and the returns that the customer can get from those solutions actually defines the kind of prices at which we can sell and the kind of margins that we can command on those products, right? In traditional manufacturing, like you said, if you're just building something to print, your cost is basically nothing but a function of your raw material cost, your manpower cost, and then whatever margins you're allowed to take. But that's not the case in our scenario. If I'm saving $1 million for my client, I have all the right to charge $1 million to him, even if I've built it for
When you
$500,000.
say you are saving $1 million by moving their engineering from Europe to India, or are you saving $1 million in their production line? What do you mean when you say you are saving them $1 million?
So think of one of the recent scenarios, for example, right? There is a particular fabricated product that we built for one of our customers. That product is a very high consumption kind of product, sold for about $50 in the local markets. But when the client came to us, the challenge in front of us was, how do we reduce this consumable cost that is something that he's not able to manage at his factory, right? We went around the manufacturing ecosystem. We looked at some manufacturers who could really produce the exact same box. And you'll be surprised to know that the cost of production of that product was double in India compared to what they were actually producing it for in Germany, right? And from there, to engineer a product at 50% of that cost, of the cost in Germany, and be able to save that money for the customer, actually helping him solve the economics of the product he's manufacturing for his client, right, is the reason why we are able to command margins on these products.
I'll hold you at gunpoint on this, Himanshu. What did you do? What was the product? What did you do in engineering to reduce the cost so dramatically?
So we had to literally disruptively...
What was the product?
The product was basically a fabricated steel product, right? But the fundamental change was, we had to change the manufacturing processes, right? You cannot go with the standard welding machines, bending machines, etc., right? You have to rethink the product ground up. You have to change the manufacturing process, and you have to design it for the scale that you want to really achieve. Manufacturing processes need to be designed or decided based on the scale of production, the cost targets that you really want to achieve.
And obviously you said manufacturing is machine, material and manpower, right? Where did the reduction come from? Like, did the machines change, which I would assume would not have changed. So on the other two pieces, where did you get to so much amount of reduction?
So I think elimination, right? Eliminate as much as you can, right? Eliminating some processes that were unnecessary, making sure that the raw material comes in a form that does not need to be reprocessed, making sure that the welding, etc., that is being done can be done at a scalable level with the right kind of fixtures, with the right kind of toolings, right? And then finally, making sure that the logistics and the products are designed in such a way that you don't lose out on logistics costs, right? Because a $50 product being exported out of India to Germany, imagine the amount of cost it takes to really send it out to Germany. So you have to really think of the whole value chain, right from production on the ground to delivering it at the factory gate of the customer. You cannot be inefficient at any stage. Our logistics have to be fully efficient. If my container allows me 20 tons of load, I have to make sure that I am touching 19.9 tons.
Got it.
We're actually, another interesting aspect here is, some of the large orders and queries we're getting right now are actually for skid-based systems. Now, these are entire systems which go in, designed to fit in a container, right? These are 3 or 4 containers that are assembled on site and merged together. And, we do the engineering to eliminate all hot works on site, very, very fast sort of setup time. I think we can set up skid-based systems in close to 10 to 15 days, pretty complex ones with no hot works on site and minimal manpower. So we can go all the way from the components parts Himanshu is talking about to entire systems, right, for factories.
Correct.
And again, skid-based systems, if you think about it, it's a sub-assembly with a very high manpower component and a huge requirement of engineering.
Maybe I can just quickly add to that. A lot of these large production plants require so many different machines. And when you're setting up a plant, everybody knows you need to weld stuff, bring material, load, unload, all of that has to be done. But if you think from the Western concept, if you think about the developed countries which are our customers, right, you cannot afford to have hot works happening at site, the amount of safety required to conduct all those activities, the shortage of manpower and the time it takes to install these large setups within that plant. Now, if you have to be competitive in the market and you have to charge margins, you have to make sure that your systems are modular, they're pre-installed. So some of these skids that Karan is talking about are absolutely zero hot work, right? All of the hot work happens here and you just assemble the Lego blocks in your factory. The manpower required for installing and commissioning those systems, because now you're not installing individual machines, you're installing full skids which just come together seamlessly. Your manpower requirements and the time required for installation and commissioning at site comes down by almost 90% in some of these cases. That is what really allows us to charge the margin that we do.
Got it. Understood. One part of the challenges is obviously margins. The second challenge that most B2B commerce companies face is working capital. And obviously you've solved it in a very interesting way. So what's the working capital in engineering, and how have you gotten to a point where instead of investing in working capital, you get free cash flow?
Yeah, so I think we benefit from a lot of different norms in the industry from over here. Number one, the protected Indian market has probably one of the worst working capital terms in at least the SME end, right? Maybe a 10% advance, 30% phased out, 20% held back as a performance bank guarantee for sometimes up to a year. Fortunately for us, China set the tone for the world, right? China, pretty much everything happens 100% pre-dispatch. Right? So you do the FAT in whatever Chinese factory or virtually, and 100%. So exporting that quality out from the customer side, we have a right to command for 100% advance, right? With our suppliers over here, we obviously don't want them to have as bad working capital terms as they do have in India, but definitely we have wiggle room is there as well. So the worst working capital term we have is, in one case is, just 30% at delivery, right? Because you lose that 1 month in shipping, but that is also subsumed by the margin, which means no net working capital impact for us.
Got it. Understood. Couple of quick questions before we wrap up. First, what's the role of AI in manufacturing?
Very interesting. So I think AI, obviously a very commonly used term nowadays everywhere, but fundamentally for us it remains a large language model, right? We can't say that engineering solutions can be built with AI, right? But a lot of the work that we really do on a day-to-day basis, and the consistency and uniformity of the output that we really need to generate for our clients, right? That has really changed quite a lot with the help of AI.
So, very interesting to hear about the margins, the working capital cycle. For non-linearity, is there a role of tech in engineering and manufacturing? And if yes, how does tech help you in your day-to-day?
So I think, look, the kind of projects, the kind of customers we are dealing with, right? I've never seen a project in my life which is not running late, right? Every customer is in a hurry. They want their deliveries fast. They want their quotations really fast. But imagine you're doing a project which is a multi-floor building. You've got to take care of windows, doors, floors, panels, everything for that customer. And you need to really churn out all of these quotations with the right spec at the right costs to your customers, right? I think that is the role of tech for us. How do we churn out a lot of these quotations really fast? How do we really catalog products quickly for our customers? And at the end of the day, even taking products from the Indian ecosystem to the market in a very, very short period of time, right? That's probably the biggest role of tech for us.
Very interesting. So obviously now you've spent time on your demand, your supply, margins, working capital. What are the big challenges that you guys have faced in the past 18 months building Wootz?
I think one of the biggest challenges has been, hiring for the right talent. Extremely difficult to really attract, train and retain this kind of talent that we require, right? One of the things that we've done recently is our GT program that we've started, really inspiring and catching these young engineers early, right? Training them on the ground, training them with international exposure, making sure that they understand the context of that market and really build those as leaders for our company as well, for different sectors and different categories that we are operating in. That's one challenge that I kind of deal with on a day-to-day basis?
Customer side, of course, trust, right? Building a brand, a trusted engineering brand takes ages. I mean, look at the most common, names, Mitsubishi, etc. These are 100-plus-year-old companies, right? We are trying to disrupt that very, very quickly. Building trust takes time. There is very strong inherent traits of enterprise sales in our business. There's a $12 billion customer in the US, finally on the verge of, we've qualified everything. We've been under trials for 6 months, right? From evaluation of Himanshu and me, the company, all our suppliers, certifications, costing across multiple products. It's a 6-month cycle, right? But you do know that the customer is moving close to $110 million of procurement to India. So getting that foothold, building that trust, compounding that trust over time takes time. So we have to have a funnel thinking maybe 2-3 years ahead also sometimes. So that is challenging. It requires, we aren't the most patient people, but it requires you to develop some bit of that. But at least we found having 20, 30, 40 or such leads to work on a day-to-day basis keeps us motivated. So yeah, that's definitely a challenge.
Got it. What's the vision with Wootz.work? Where do you see the company in 7, 8, 10 years?
I think it's probably the most exciting time for manufacturing and engineering in India, at least in our lifetime, or probably since Wootz steel was made. So, I think our vision is pretty simple. We understand our business, we understand how it works, we understand what we need to do and where we need to invest, right? So our vision is, of course, to make ourselves the world's largest engineering company, engineering solutions, and maybe even getting into products, who knows, right? Starting point over the next 3 or 4 years, I would very comfortably see us at a 100 million plus a top line. It doesn't take us too many customers to get there. It takes us about 15 to 16 customers to get there. It also takes us only about 40 suppliers who work very closely with us, completely contracted out facilities, right? So that would be an intermediate goal. Profitability wise, our margins are great. Using technology, we are managing to take the cost below GM down significantly. So there's no reason why you can't have a 20%, 15% PAT company, right, with no working capital and 100 million plus revenues. There have been some fantastic IPOs recently, as you and me keep discussing, with engineering companies. And it's so good to see that the market is finally realizing real drivers, right? Like revenue, customers, recurring customers, margins, capabilities, as opposed to just GMV. So super exciting times. I think outcomes may look traditional, but there's a lot going on under the hood.
Got it. Good. Now we'll do a bunch of rapid fire questions. You don't have a choice to think, so we'll ask questions quickly and would love to get your honest answers. So to both Karan and Himanshu, maybe first I'll shoot Himanshu and then Karan. If not Wootz, what else would you have been doing?
Probably a professor.
Karan?
Maybe in VC, I don't know.
One advice quickly for startups starting in engineering and manufacturing in India.
Spend time on the shop floor.
It is the hardest thing you will ever do.
Okay, very interesting. One, and this is maybe for you, Karan, one interesting anecdote from a global client pitch.
It's okay,
Whether you go for a positive outcome or a negative outcome.
Yeah, I think there was a time where we had a couple of large orders, and there's obviously a period in which things don't happen as well as the customer wants to. There's always that between supplying a complex system and that. And the customer was an aggressive gentleman, and I was called for a meeting somewhere remote, and I told Himanshu, I sent him my live location. I said, Himanshu, I don't know why I have a feeling I'm not going to come back. So you can track me, my wife, every month sleeping back home. I'm in the UK. So that's on the bad side. On the good side, things happen also. Customers call you up late night. Karan, the part you had sent me just got accepted by the end customer. I just thought I should tell you. I can't sleep the rest of the night. I guess I call him up, I wake him up, and I do it like really, that feels amazing for us. Again, our sleep cycles are super weird. I sleep 2-hour stints because we start all the way from New Zealand, which is 4 a.m., all the way up to West Coast in US, which is pretty much a 24-hour cycle.
How do you solve for conflict between the two of you?
It's painful. We are quite neatly divided in terms of supply and demand. So calls on either side clearly rest with him or me, right? But there are times conflicts do happen that, a timeline was committed by supply and not met, right? But I think we're mature adults now. We know that Himanshu knows that it's him to blame if that timeline has not been met. So then I sort of support him with the customer, and if I've overcommitted something and not happened, haven't got the right information, that's on me, he supports me. There's conflicts every day. Yeah. Like we just recently quoted on something with a record 45 days of manufacturing. This would normally have taken us in the previous cycle of orders 90 days.
Got it. Himanshu, what's the role of AI in manufacturing?
So I think, as a whole, technology is extremely important for us, right? Obviously, with the AI revolution, technology has become more accessible for us, right? So whether it's building software in a couple of days, building databases in a few days, we've been able to build a very unified system for costing of products, for quality inspections, for making sure that the quality produced on the line is actually absolutely right? All of these things for so many different sectors, so many different categories of products is extremely difficult to solve humanly, right? And that's where I think AI is every day giving us advantages, which I think we're going to reap for the next few years. It has accelerated our technology adoption cycle. Some of the software that we've built, like one of our browser products, which is kind of built on the lines of being the best file viewer for any engineer across the world, right? And this software was built with zero programming people in our company, right? I think it's a huge boon. I am coding day and night sometimes with the help of AI, correcting my code, not spending weeks and days, or making sure that there are no errors in the output code, right? All of that is like amazing things that we couldn't have imagined. In fact, when we started the company, we didn't have all of this.
On the customer side, we've now managed to build configurators, right? For a customer to literally on his iPad, choose a certain type product and on the fly create the product and enter the dimensions. So that's also been amazing from at least the sales side.
Okay, great. Thank you, Himanshu and Karan, for spending the time. It was fantastic talking to you guys, talking about sort of your backgrounds, the Wootz.work journey, your vision, and hopefully in 5 to 10 years, we have a much broader, wider and much better engineering ecosystem in India, where hopefully you guys flourish, but there are a lot more other companies building in engineering for India and for the world as well. So thank you so much.
Thanks, Sudipto.
If you like this episode of Zero to Infinity, there are so many more that you must check out. If you like Indian startup content, hearing about founder journeys, or knowing more about emerging sectors that we're investing in, Zero to Infinity is the channel that you need to subscribe to.